Okay, I'm going to talk about applications of some derivatives. I'm going to start with physics and engineering, moving on to business and then to geometry. There is a class in the room next door. It gets loud off and on, so that you may hear it over this on occasion. Going to start with this example. On Earth, an object thrown upward from 100 feet above the ground at 45 miles per hour, which is 66 feet per second, would have a height of s of t equals negative 16t squared plus 66t plus 100. Where this is the starting height, this is the initial velocity, and that is related to the power of Earth, the force of Earth's gravity. It would vary on other planets. I'll use Mars in the second example. So, A, find the velocity function v of t, and B, find the velocity after 1.5 seconds. So do. Okay? A, v of t equals s prime of t, which means the derivative of this. So that'd be negative 16 times the derivative of t squared would be 2t to the first. The derivative of the constant is of something times t is just the something, and the derivative of the constant is 0. So the derivative, so v of t, the velocity function, is negative 32 t plus 66. So B, v of 1.5 seconds is negative 32 times 1.5 plus 66. This is negative 48. And that is negative 48 plus 66. It's still going up at 18 feet per second. Okay? All right. I'm going to change this to example 2 on Mars. An object thrown up at 45 miles per hour, which is negative 66 feet per second, would have a height of s of t equals negative 6.1 t squared plus 66t plus 100. So, A, find the velocity function v of t. B, find the velocity after 1.5 seconds. C, find velocity after 10 seconds. Okay, on Earth it would have already hit the ground. Okay, on Mars it would still be in the air. Do A, v of t equals s prime of t, which is negative 6.1. The derivative of t squared would be 2t to the first. The derivative of 66 times t would just be the 66, and the derivative of the constant would be 0. So that'd be negative v of t is negative 12.2 t plus 66. B, v of 1.5 equals negative 12.2 times 1.5 plus 66. So, negative 12.2 times 1.5 is negative 18.3 plus 66. That is 47.7 feet per second. Still much faster than it would have been on Earth, as we saw in example 1. C, v of 10 would equal negative 12.2 times 10 plus 66. So that's negative 122 plus 66 negative 56 feet per second, meaning a fall at 56 feet per second. That's what that would mean as far as application. I'm going to pause here and switch to business. Okay. Marginal cost is a derivative. It's the cost of one more. Revenue, marginal revenue. Revenue of one more, it's R prime of X. And marginal profit, the profit of one more, which is given by P prime of X, the derivative of each. Okay? So I'll start with the marginal cost. The marginal cost, if C of X is 3.85, so let me go ahead and read the problem. I'll put B up too. Marginal revenue. Okay? Marginal cost. So a company makes Gibbets, a fictitious device, the cost function. C of X equals 3.5X plus 1450. Revenue, R of X is negative 0.035X squared plus 923.4X. So if the marginal cost is if the cost is 3.85X plus 1450, then C prime of X, the marginal cost, is going to be the derivative of this. So 3.85X, well, the derivative of something times X is just a something, and the derivative of the constant is 0. So the marginal cost is 3.85. Which shouldn't surprise anybody because it takes, the fixed costs are $14.50 and it costs $3.85 to make a unit. Okay? Marginal revenue. If R of X equals negative 0.035X squared plus 923.4, the marginal revenue at R prime of X would be negative 0.035 times 2, X the first, plus, that's X originally, and the derivative of something times X is just the something. So, R prime of X equals negative 0.07X plus 923.4. All right, so I'm going to pause here and put two more examples on the board, okay? I'm going to darken these up to do this again, okay? So, derivative, R prime of X is negative 0.035, and the derivative of X squared would be 2X the first. You go down a power, and the derivative of something times X is just the something. So the marginal revenue is simply negative 0.07X plus 923.4. That's the marginal revenue. Okay? All right, I'm going to put examples B and C. I'm going to put additional parts here on the board. C, find profit function. Find profit function. Okay, well, it's R of X minus C of X. And that's capital P of X, or capital not P prime. All right, so that would be negative 0.035x squared plus 923.4x minus 3.85x plus 1450. All right? So, negative 0.035x squared plus 923.4x, distribute this, negative 3.85x minus 1450, which is negative 0.035x squared. I'm going to have to do that subtraction. 923.4 minus 3.85 gives me plus 919.55x minus 1450. Okay, so that's the profit function. D. Find marginal profit. Well, P prime of x is negative 0.035. Derivative of this is 2x, the first. The derivative of something times x is just the something. And the derivative, forget the x, that's the derivative of this is just the number, and the derivative of the constant is 0. Okay, so P prime of x equals negative 0.07x plus 919.55. E, find marginal profit of 13,000 units. Okay, so we're going to find the profit on the marginal profit on 13,000 units. Well, P prime of 13,000 equals negative 0.07 times 13,000 plus 919.55. So, negative 0.07 times 13,000 is 910, negative 910, plus 919.55 gives me $9.55 per unit. Okay? So they are still making a profit on this. All right, let me move on to another example, another topic. Okay, for the third topic, we're going to talk about geometry. Consider the function f of x equals x cubed minus 9x squared plus 17x plus 51. A, find the slope of the tangent at x equals negative 1. So, do A. F prime, I need f prime of negative 8. Okay, that's where the slope is going to come from. Slope of the tangent line to f of x is f prime of x. So if we're looking for the slope to the tangent at x equals negative 8, I need f prime of negative 8. Well, f prime of x is 3 You go down a power to x squared minus 9 times 2x to the first plus the derivative of 17x is just 17 and the derivative of the constant is 0. So f prime of x equals 3 times 3x squared minus 18x plus 17. So f prime of negative 8 equals 3 times negative 8 squared minus 18 times negative 8 plus 17. So 64 times 3, 192 plus 144 plus 17, 353. Okay, so slope of tangent line would be 353. A really steep slope. B. We're going to do y minus y sub 1 equals m times x minus x sub 1. Okay? But this is going to be f prime of x. Okay? So the point is 45 and 6. In this case, it's going to be f prime of 6. Okay, so I need f prime of x first. So that would be, I'm going to pretend that we're doing this from scratch. So that would be 3, go down a power to x squared, minus 9 times 2 will go to the front, and the power of x will go down 1. And the derivative of something times x is the something. And the derivative of the constant is 0. So this would be f prime of x would be 3x squared minus 18x plus 17. All right, so f prime of 6 f prime of 6 would be 3 times 6 squared minus 18 times 6 plus 17. So 36 times, that's 36. 36 times 3 is 144. I believe 18 times 6 is also 144. It's actually 108. I messed that up too. Try this again. 36 times 3 is 108. 18 times 6 is 108. And this just leaves me 17. Okay, so that's the slope. So y minus y sub 1 times m times x minus x sub 1. Well, that's going to be y minus the 45 equals 17 times x minus the 6. So y minus 45 equals 17x minus 17 times 6, 102. Go ahead and add the 45 back. And y equals 17x negative 102 plus 45 minus 57. That would be the slope of the tangent line. So this is the final answer right here. Okay, final answer. So the equation of the tangent line to this point right here. Okay?